Hello guys, welcome to my YouTube channel Vishwaguru, a problem solver. Today's session, we are going to discuss a numerical example on the topic of Newton's law of motion, D'Alembert's principle, or connected body, whatever. Okay, let's go to the numerical. Two bodies, A and B, of mass 80 kg and 20 kg are connected by a thread and move along a rough horizontal plane under the action of a force 400 Newton applied to the first body of mass 80 kg as shown in figure. The coefficient of friction between the sliding surfaces of the bodies and the plane is 0.3. Determine the acceleration of the two bodies and the tension in the thread. Okay. Here, there are two bodies, A and B. A is having a mass 80 kg. B is having a mass 20 kg. These two bodies are connected by using a thread, and these two bodies move along a rough horizontal plane under the action of a force 400 Newton, which is applied to the first body. The coefficient of friction between the sliding surfaces of these two bodies and the rough horizontal plane, that is 0.3. We have to determine the acceleration of the two bodies, which is constant, because here both the bodies connected by using a thread and is moving under the action of this 400 Newton. So both the bodies will have a same acceleration. So that acceleration we have to calculate. And what is the tension in the thread which connects the body A and B? Okay. So these things we have to calculate. Guys, in this video description box, I have given a link of the video, that is D'Alembert's principle, the overview of the D'Alembert's principle. So in that video, we discussed elaborately the D'Alembert's principle for objects moving on a rough horizontal plane, a rough inclined plane, and if any vertical motion, like a motion of a lift, the connected bodies in a vertical motion. So the D'Alembert's principle for these three cases, we discussed elaborately, and the forces, what are all the forces will act on the bodies, that everything we discussed in that video. Okay, that is the overview of D'Alembert's principle that I had given in the description box. Okay, so before watch this video, it's better to see that video for a reference, because that will act as a reference for this numerical. Okay, free body diagram of object A, that we are going to do here. Okay, first thing, this object is lying on a horizontal surface that we discussed already. Okay, and then it is on a rough horizontal surface. Here, now we are going to discuss what are all the forces or acting on this object. Okay, that means object A, that we are going to discuss here. Okay, that is, this is object A. which is having 80 kg mass. And then we know that, as we discussed in the reference, its weight will act exactly downward, that is mg, and equal normal reaction that will act exactly upward, that means R1. Here, this body A and B are connected by using a thread. So in this thread, the tension, which is equal, that means two forces equal in magnitude and opposite in direction, that will act like this. So if we separate here for the object A, the tension on the string that will act towards this direction. And then here, obviously, the external force or the applied force 400 Newton that is acting this direction. Okay. And here, both the bodies A and B, these two bodies are moving towards left side under the action of the applied force 400 Newton. So when the object is moving towards left side on a rough horizontal surface, the frictional force that will act opposite to the direction of motion. So for this body, this is the direction of motion. That means both the bodies, this will be the direction. Okay. So we know that the frictional force opposite to the direction of the motion. So the F mu that will act opposite. Okay. Then here you can see, as per the D'Alembert's principle, summation of the external forces that equal to the inertia force, that is also opposite to the direction of motion. Here, the direction of motion towards the left side. So the inertia force, MA, that also will act towards right side. Okay. So here, two masses we are going to consider. This is body A. And then next we are going to discuss for the free body diagram of the body B. So these values, which are all used particularly for the object A, I'm going to mention with the suffix 1, like M1. Okay. So here the frictional force, that is also F mu 1. Okay. So then here this will be in the dynamic equilibrium. That is the D'Alembert's principle. Okay. When you consider the algebraic sum of the external force that equal to the inertia force, then the body is in dynamic equilibrium. Okay. So when an object is in equilibrium, we can use the three principles: summation of horizontal forces equal to 0, algebraic sum of the vertical forces equal to 0, the algebraic sum of moment about any point that equal to 0. Okay. So here we are going to use the first two, that is summation of horizontal forces equal to 0 and then summation of vertical forces equal to 0. First, summation of vertical forces equal to 0, since this is in dynamic equilibrium when you consider the inertia force opposite to the external, that means algebraic sum of the external forces. Okay. Summation of vertical forces equal to 0. So here, what are all the vertical forces are acting? M1G, that is acting towards left side. Then R1, that is acting towards upward. Okay, this is acting towards downward. R1, that is acting towards upward. Okay, so we can write R1 that equal to M1G. Okay, then summation of horizontal forces that equal to 0. Here, what are all the horizontal forces are acting? 400 Newton, that is acting towards left side. M1A, that is acting towards right side. T, tension in the string, that is also towards right side. Frictional force between the object A and then the rough horizontal plane, that is also acting towards right side. So this we can write as 400 Newton. This is the left side force that equal to the summation or addition of all the right side forces. We can write T plus M1A plus F mu 1, the frictional force acting on the object A and then the rough horizontal plane. Okay, everything will be on the right side. So here we have written like this. Then we discussed already the frictional force. We can write mu, coefficient of friction multiplied with the normal reaction. Okay, so here R1 equal to M1G. So from this R1 we can calculate, okay, R1 we can calculate the mass of the object A, 80 multiplied with 9.8. Okay, so R1, that value equal to 784 Newton. Okay, 784 Newton. Okay, then here F mu 1, that equal to mu multiplied with R1, coefficient of friction multiplied with R1. So here substitute the coefficient of friction value 0.3. Coefficient of friction is 0.3 multiplied with R1 784. So we will get the frictional force acting on between the object A and then the rough horizontal plane, that equal to 235.2 Newton. Okay, 235.2 Newton. This is the frictional force acting on the object A and then the rough horizontal plane. So now substitute this value here, okay, in this equation. So we can write 400, that equal T plus, substitute the M1 value, 80 A plus 235.2. So by rearranging this equation, we can write T plus 80A, that equal to 400 minus 235.2. So we can write T plus 80A, that equal to 164.8. Okay, so this is the first equation. Then we are going to consider the free body diagram of the second body. Okay, free body diagram of the object B. Okay, so here consider the object, that means rough horizontal plane. This is a rough horizontal plane, and then the object is moving on this surface. Okay, so now we are going to consider what are all the forces will act on the object B. Here you can see this object B is connected by using a thread with the object A. So here the tension for the object B that will act towards this direction. Okay. The tension will act towards this direction. This is the object B. As usual, the weight of the object M2G that will act exactly downward. The reaction force R2 that will act exactly upward. And then here this object direction that is also towards this direction, towards left side. Okay, this is the direction of motion of the object B. So here the frictional force between the surface and then the object that will act towards left side, opposite to the direction of motion. As per the D'Alembert's principle, the inertia force that is also will act towards the opposite to the direction of motion, that is M2A. Okay, so here if you consider summation of vertical forces equal to 0, there are two vertical forces are there. R2 is acting upward, M2G that is acting downward. So R2 that equal to M2G. M2 value that is 20 kg, G that is 9.81. So if you substitute that values, that is 20 multiplied with 9.8. So we will get R2 that equal to 196 Newton. Okay. Then the frictional force that we can calculate F mu 2 that equal to the coefficient of friction multiplied with R2. So the F mu 2 that is coefficient of friction, that value is 0.3, R2 that is 196. If we multiply it, we will get 58.8 Newton. This is the frictional force acting on the body B and the rough horizontal surface. Okay. Then summation of horizontal forces equal to 0. Here there are three forces are there. Tension, that is the only one force acting towards left side in the direction of motion. Other two horizontal forces, inertia force, which is numerically equal to the product of mass and then the acceleration, that is acting towards the left side, and then the frictional force that is also acting towards left side. So we can write T that equal to M2A plus F mu 2, or we can write T minus M2A that equal to F mu 2. Okay. So here we know the value of M2 that is 20 kg, and then we know or we calculated the frictional force on the second object 58.8 Newton. Okay. So if you substitute both the values, so we will get the second equation with the two unknowns, tension and acceleration. Okay. So when you substitute the value of M2 in the previous equation, T minus 20A that equal to, instead of F mu 2, that is 58.8. Okay, 58.8. So this is the second equation. Okay, so we have two equations with the two unknowns, tension and acceleration. Okay, so now by solving these two equations, 1 and 2, so we will get the value of the two unknowns, tension and acceleration, which is the final requirement of this numerical. Okay. So the first equation, T plus 80A that equal to 164.8. The second equation, T minus 20A, that equal to 58.8. Okay. So here it's better cancel the T. Okay. So change the sign. That means first equation minus second equation. Okay. So this coefficients on the second equations, we have to change the sign. So here the plus T and then the minus T. Okay. Both cancelled each other. This we can cancel each other. Then 80A plus 20A. So we will get 100A, that equal to 164.8 plus, sorry, minus 58.8. So we will get 106. Okay, 164.8 minus 58.8, we will get 106. So here acceleration A equal to 106 divided by 100. So if you divide, we will get the value of acceleration. That means just two decimals this side we will get. That is 1.06 meter second power minus 2. So substitute the value of acceleration in any one of the equation. Okay, say 1 or 2. Okay. So we will get tension T minus 20 multiplied with 1.06, that equal to 58.8. So from this we will get tension equal to 80 Newton. Okay, if you simplify, we will get the value of tension equal to 80 Newton. Okay. So these two are the final requirements of this numerical. Okay. Two bodies A and B having mass 80 kg and 20 kg connected by using a string or thread and move along a rough horizontal plane under the action of external or applied force 400 Newton to the first body. Coefficient of friction between the sliding surfaces of the bodies and the plane, that will be 0.3. We have to calculate what is the acceleration of the two bodies and then what is the tension in the thread between A and B, that we have to calculate. So free body diagram of A, then we consider what are all the forces or acting on the object A. First, summation of vertical equals 0, R1 equal M1G. We calculated the value of R1. So from that, we can calculate the frictional force, mu R1 on the first object. Then summation of horizontal force, that equal to 0. 400 Newton, that is acting towards left side, except 400 Newton, that means the applied force. The other forces, inertia force, M1A, tension in the string, T, frictional force on the object A. So everything on the right side. So 400 equal T plus M1A plus F mu1. Substitute the value of M1 and F mu1, the calculated value. So we will get, and by simplifying, we will get T plus 80A equal 164.8. This is the first equation. Then free body diagram of B. Okay. Then we considered all the forces acting on the object B. Then summation of vertical force equals 0, since when you consider inertia force, that will be in dynamic equilibrium. So R2 equal to M2G. From that we calculated the frictional force on the object B. Then summation of horizontal forces equals 0. Here what are all the horizontal forces are acting? Towards left side only tension is acting. Towards right side M2A and a frictional force of the object B is acting. So left side force equal to the right side forces. That means algebraic sum of the right side forces. So T equal m2a plus f mu 2. So t minus m2a equal f mu 2. Substitute the value of m2 and f mu 2, the calculated value. So we will get the second equation. So now by considering and solving the forces acting on A and B separately, we got two equations with the two unknown, tension and acceleration, which is the final requirements of this numerical. Okay, two equations with the two unknowns. So by solving 1 and 2, that means first equation subtracted with the second equation, we got, by cancelling the t, we got the value of acceleration. Then by substituting the value of acceleration in any one of the equation, here we substitute in the second equation, we got the value of tension. Okay, so acceleration of the body, that is 1.06 meters second power minus 2. Tension in the thread, that is 80 Newton. So these two are the final requirements of this numerical. Okay. Okay, guys, I hope you all understand this numerical. Don't forget to subscribe this my channel, YouTube channel, Vishwaguru, a problem solver. Because in upcoming videos, we are going to discuss many solved numericals like this on the topic D'Alembert's principle and relative velocity, projectiles, etc. Okay. So don't forget to subscribe my YouTube channel, Vishwaguru, a problem solver, for more videos. Thank you guys. Thanks for watching.